Okay, so now let's take an example that shows how the Rolle's theorem is satisfied. This is number 12 from your textbook. So the question says, determine if Rolle's theorem applies, and if so, find the points that are guaranteed to exist by Rolle's theorem. So here the function is a polynomial, which is very nice. As a matter of fact, the first time the mathematician who came up with this theorem wrote the theorem, he was working with polynomials. Okay, so we have a function on a closed interval. So let's go through the criteria for Rolle's theorem. Is f continuous on the closed interval? Yes, because it's a polynomial, and polynomials are continuous everywhere. So that first condition is satisfied. 2, is f differentiable? Well, the derivative is 3x squared minus 6x minus 8. It's also a polynomial. So this exists everywhere. So in particular, f is differentiable on the open interval -2, 4. So there you go, the second condition is satisfied. And let's take a look at the third condition. F of a, so here that's f of -2. Okay, so if I plug in -2 into my function, let's calculate this. So that's -8 minus 8 plus 16. It's equal to 0. Okay. F of b, well, the check mark doesn't go here yet. Let's see. F of b is f of 4. So that would be 4 cubed minus 2 times 4 squared minus 8 times 4. So that's 64 minus 32 minus 32 equals 0. Okay, great. So we've established that these are equal. So f of a equals, these two are equal. So then we've established that the third condition is satisfied. So our conclusion is that f satisfies the requirements of Rolle's theorem. In other words, there exists at least one number c such that f prime of c is equal to 0. And to find this number, we just solve f prime of x is equal to 0, and the solution, we just call it c. So let's actually solve. F prime, we saw earlier, was 3x squared minus 4x minus 8. So we set that equal to 0, and we're going to solve this. So let's see here. Maybe we can factor this. 3x and then x. So maybe minus 2, or minus 4 rather.